Venturi meter. This is another way of measuring flow. As we have discussed before, measuring flow is not easy like the horsepower. So it is typically measured indirectly. So flow rate Q is not easy to measure directly in a system. Now we can always collect a bucket of flow and see how much time it takes, and then you can measure that way. However, any fluid system, they are kind of closed loop, so you cannot really take the fluid out when it is running in operation. You need to know the flow in the closed system. So the way it is done, as we have explained in the Orifice meter, basically a standard plate like this, and then it is attached here, just cutting this pipe, and with two flanges it just kind of pressed together so it doesn't leak or anything, and then this standard hole there, and then because the flow is restricted, so the velocity will increase here. So velocity increase means the kinetic energy will increase by the sacrifice of the potential energy or pressure energy. So as you can see here, there will be a pressure difference because this side is high pressure, so it will press the manometer fluid, and then the low pressure side will go up. So this is the difference of the pressure. So once we know the difference of the pressure P2, so we can calculate the height here, and then we can always convert P equal gamma H and then put it here. So basically that H is P2 minus P1. So that's the Orifice. Similar is the Venturi meter. So it does the exact same thing. The only difference is the Orifice is a plate like this, and Venturi, it goes kind of tapered, slowly reduce the pressure by increasing the velocity, and it kind of go back to the original velocity here. Now as you can tell, it's the exact same principle. So the amount of pressure difference depends on how how restricted this flow is, and then we can correlate with some standard flow and kind of tell that how much flow is going. So you can see this equation is used for this measuring flow in the Venturi meter. This is the equation for, they're kind of similar, basically depends on the pressure difference. They measure the pressure difference and then they convert it to flow. Now the pressure difference measuring is very easy. This manometer tube is just a plastic tube, cheap, probably 50 cents, and then you can attach it there and you can see the pressure difference. So and then you can measure the pressure difference and then convert it to flow. So that's very easy. Now what's the difference between these two? As you can see, the Venturi will be difficult to design. You have to taper the pipe. If it's a steel pipe or plastic pipe, will be even more challenging. So if it's a steel pipe, you have to kind of taper it this way. So it's not gonna be easy to design. So it's gonna be very expensive. The Venturi would be very expensive compared to, oops, I lost my pen, compared to the Orifice meter. So that's one thing. And of course, because it's expensive, there are some advantages of this thing. As you can see, the pressure drops a little bit slowly, and increasing velocity goes very slowly. So there will be very less pressure energy loss in this system. And here you got this sudden heat, so it will be there will be more loss in that system in the Orifice meter. So that's the main thing. This is Venturi is very expensive to set up, and then the Orifice cheaper, but you lost some energy through it. But the measuring principles are kind of same in both cases. And of course, as you can see, if you have to taper this slowly, I lost my pen again. It takes more space, maybe a couple of feet depending on the pipes. Here only probably a couple of inches. You can cut it easily, install one of these standard Orifice meter and measure the flow.